you. First of all, it's so great to see all of you here. I can't get my undergrads to show up when their grades depend on it, so kudos to you guys. A little background just on myself. I don't totally embrace the whole Darth Vader thing. I like to describe myself as a professional planet hunter, and I've been doing this sort of as my job for about 10 years now. I grew up, from the time I was a child, I looked at images from the Voyager spacecraft when they visited the outer planets, and around that same time, the first exoplanets, so planets orbiting other stars, were being discovered, and I decided from a pretty early age that that's what I want to do. I want to find exoplanets orbiting other stars, and I've been fortunate enough to do that for a living, and really I'm excited to do that and excited to share some of that with you this evening. It's really great. We've been doing this for approximately 20 years now. The first real standard exoplanets were discovered in about 1995, and it's just been exploding ever since. And literally since that time, whenever we apply for telescope time or funding or any kind of overall interest in this field, this is what we promise, okay? We're looking for Earth 2.0. We're looking for somewhere that humans could potentially live. And just to, this is my one bit of political advocacy, this is never going to happen, okay? We're never traveling to another planet to set up shop, okay? We'd be much better off just making Earth habitable again. But still, to answer the big questions, are we alone in the universe? This is what we're interested in. You see I'm going to show a lot of artist conceptions tonight, but there's a lot of science behind that. So we're looking for something really similar to Earth, and when I talk about small planets, this is what I'm referring to. You can sort of lump planets into two categories. There are big planets that are big, gaseous, horrible things like Jupiter and Saturn, and then there are small, rocky things like the Earth and Mars and Venus. And so this is the sort of holy grail of exoplanet science, this sort of Earth 2.0. But this is an incredibly difficult problem, and the reason is that planets are very close to their stars and they're very faint. And so the combination of those factors means that you have to look for sort of indirect evidence of their existence. And even that indirect evidence is sometimes very small. And so I show here the example of planets, and this is from the Kepler spacecraft program, which was looking for planets through the technique of staring at stars and waiting for them to get fainter because a planet is, we call it transiting, but you might understand this as eclipsing, okay? The planet passes between the star and you, and so you can sort of see here, this is what it looks like when a planet the size of Jupiter, one of these large gas giant planets, passes in front of the star. And even a large planet like this blocks only about 1% of the star's light. And so when you downsize that to something the size of the Earth, then your signal degrades accordingly. And so you can sort of, all of these problems are difficult, and no matter what the exoplanet is, it's hard to find. But you can sort of batch this into large and small. It's easy to find and hard to find. Okay? The bigger planets, the closer planets to the star are easier to find. And so while we promise our funding agencies that we're going to find these planets where aliens are going to live, where we could send astronauts so they can take their helmets off and walk around, we have this catalog of thousands of planets that are instead just horrible places, like places you would absolutely not want to go under any circumstances, okay? They're so massive you would be instantly crushed under their gravity, but in addition to that, they're thousands of degrees, they're just hot as hell, they're just poisonous atmospheres, just terrible things. And this is sort of fun to think about. Now, the galaxy and by extension the universe is such a huge place that you can extend this axiom. Anything that's not prohibited by the laws of physics has to occur somewhere out there. And so any world you can imagine where the laws of physics still apply, no matter how horrible the end result is, it exists somewhere out there. And our existing catalog of exoplanets already contains a lot of planets that sort of meet those descriptions. And so what I want to do tonight is just sort of spoil your travel plans and look at 10 of the worst exoplanets that I can come up with looking through the catalog. And so I'll lump these into some categories going from the most mundane to the most extreme. So the first category is the one that sort of makes the most sense. It's bad weather, okay? Places you wouldn't want to put on your bathing suit and go lay out on the beach. And this is sort of already intuitive because so many of the planets in our own solar system are horrible conditions. But it does get rather extreme. So let's start to look at some of those. The first, and this is the first thing, astronomers are terrible with naming planets. This is the worst thing when I give public talks to kids and I talk about exoplanets. The first thing they want to know is, what are their names? It's like, well, this one's B, this one's C, this one's D, okay, that's terrible. So they all have catalog names. So the first HD 80606b, okay, so this is a planet that really, its orbit looks more like the comets of the solar system. So you look at orbits of the planets in our own solar system, Earth, Mars, Jupiter, their orbits around the sun essentially look like circles. And so Kepler's laws say that the orbits of all planets are ellipses, but you can practically ignore that for the Earth. Not so for this planet. This is an actual map of this planet's orbit. It's very eccentric, it's very elongated. And so at its most distant point, it's fairly far from the star, and it moves in closer, and it gets incredibly close to the star. So for those of you who know these things, its eccentricity is something like 0.97. It's almost a straight line. And so what happens is, at the closest approach to the star, it moves in very quickly, and this closest approach takes approximately 8 hours, over which the average temperature on this planet increases by 1,000 degrees Celsius, and those are bigger degrees than Fahrenheit. And so again, those of you who are used to Louisiana summers, yes, it's terrible, but this really puts that to shame. And so this is not a planet that you would want to be there, especially for the summer. So moving on, it's bad enough with one star. But one of the things, again, going back to the Kepler mission, one of the things we've learned is that approximately half the stars in the galaxy are multiple stars. So there are 2 or more stars that orbit each other. This is not new news, but what was new from Kepler is that we learned that these binary or triplet stars, whatever, they actually have planets of their own. And so one of the most famous cases is Kepler 16b. And this planet got so much press that NASA actually made, you may have seen these travel posters that sort of give this artist's description of what a view from that planet might look like. And they actually show a person standing, really this would have to be a moon of the planet. This is another gas giant planet. Whether it's a planet or a moon, you don't want to go there, okay? They tell you in grade school that the reason we have the seasons is not because the planet is getting closer or farther away from the star. That's not true in this case. These stars are orbiting each other, and so as they do that, the larger star, the hotter star, which is really where all of the light, the energy supporting any kind of life would come from, is actually moving further and away from you. Those of you who have seen the movie Pitch Black with Vin Diesel might also be familiar with this. The stars eclipse each other, which blocks even more light from the star and leads to even more radical swings in the temperature. Again, life on Earth is really dependent, especially advanced life, is really dependent on really stable conditions over long periods of time. Okay, the amount of light you're getting from the sun varies by like 1% at the most. And this is causing swings much larger than that. So again, seasonal variations put anything you see on Earth to shame. This would be, your outfits you wear from summer to winter would just be absolutely insane. So yeah, not a great time, and it only gets worse from here. Trust me. Here's a great one. I love this. The artist's conception. It's absolutely gorgeous. This is HAT P11b, and again, great name. This is a relatively small planet. It's somewhere between the size of Earth and the sort of mid-sized planets of the solar system, Uranus and Neptune. And so a small planet, the kind of things that we would start to think of as habitable, we can actually detect water vapor in the atmosphere of this planet. So that's really exciting. Water is one of the things we know we need for life. And there are weird radio signals coming from this planet. Like, could this be ET phoning home, or not phoning home, but phoning us? Let me go ahead and spoil this for you. No, it's not. This is way too hot to support any kind of life as we know it. And it turns out the best hypothesis we have for these weird radio signals is horrible lightning storms that are 100 times more intense than the lightning storms we see on Saturn, which are the most powerful lightning storms in the solar system. Yeah, you would be fried in an instant on this planet, either by the heat or the electricity. You take your pick. And then to cap off our horrible climate tour, let's go back to another Kepler planet. And this doesn't even get a planet designation. This is the Kepler input catalog number. It is disintegrating before our eyes. It is so close to the star and so hot, so the average temperature is like 2,000, 2,500 degrees. And it's so hot that this planet is blowing apart before our eyes. Everything that makes up this planet is just blowing away in the wind. And by the time the sun completes another orbit around the center of the galaxy, this planet will be completely dissolved. So I guess we're glad and we're lucky to be seeing it, while it's still there. But definitely not a place you'd want to visit. This is a whole category. As it turns out, there are a lot of planets like this. Stars consume their planets all the time. And I guess just consider yourselves lucky that we're not in danger of that happening anytime soon. So let's move on. We've looked at bad weather, and you can come up with thousands of planets that we already know of that have horrible weather. But there are some others that have interestingly horrible stars. And they're horrible for various reasons. One of my favorites, because it was discovered by a friend of mine, is Aldebaran B. And Aldebaran, you might actually recognize, is one of the brightest stars in the sky. I think it's like the 4th brightest star in the northern sky. And so it's kind of an interesting touchstone from that perspective. You might notice, again, a lot of artist conceptions I've got up here that actually have a lot of foundation in science. You see this kind of, it's not a perfect circle here. Turns out this is not a happy, healthy star. This star is in the process of dying, and so it's enlarged by many times. So here's the size of the sun, just for comparison. This star will eventually grow and completely consume its solar system, and take many of the planets in that system with it. And so, again, you talk about nice, stable conditions as being a prerequisite for habitability. That's certainly not happening here. Here's another one, great catalog name, OTS-44. So you might notice here I don't actually put at least one star in the artist's conception. Instead, you get a really nice view of the Milky Way galaxy in the background. And the reason for that is this planet actually doesn't have a star. This is a planet that has lost the evolutionary battle of planet growth in its own star system and has been thrown out of its solar system. And so it floats the galaxy unaccompanied. So in some senses, this is not even a planet. It's not orbiting a star. And so this is a planet enshrouded in perpetual night. And so maybe not a bad star, but just no star at all. And all of it, so background information, any of the energy input that supplies, supports life on a planet comes from a star, so this has none whatsoever. For the next one, I'm actually going to go old school and go back to the first planets ever discovered. So this really has a long catalog name, which I won't repeat. These are planets orbiting a pulsar, which is the dead remnant of a very large star that went supernova. These are, again, the first planets ever discovered. Discovered by Alex Volshan who, you know, being the discoverer of the first exoplanets was not enough for him. In his side job, he was, say it with me, a communist spy for Poland. Very good. I'm not making this up, this is true. He made this discovery of planets orbiting the dead remnant of a star that went supernova, okay? This would have destroyed every planet in this system, and so whatever he found here actually must have formed out of the debris of the supernova explosion that had originally destroyed this solar system. And so I refer to these as zombie planets. Whatever's there is being constantly bathed by high energy, you know, X-ray, gamma ray radiation. And so again, not a great place to hang out. Running out of time, so I'm going to move along. This is my favorite category, is the true weirdos. So this has nothing to do with the weather, has nothing to do necessarily with the star itself. It's just like completely weirdo planets. And I think in some cases these are the absolute worst of the worst. HT 189733b. Again, this is one of the oldest exoplanets we've found. But because we've known it for so long, we've been able to study it so really in more detail than some other planets. And you see here from the artist's conception, this starts to look like one of these sort of Earth 2.0 planets. It has this really nice blue sky. And this is not just some artist taking liberties with things. We actually know that it has a blue sky. And so you would think, was this an Earth-like atmosphere? It turns out the answer is absolutely not. This blue color, this planet is so hot that silicon in the atmosphere is fusing into glass. And so there are shards of freshly formed hot glass swirling through the atmosphere of this planet at hundreds of miles an hour. I cannot imagine this being a fun day at the beach. Honestly, this is maybe the most miserable planet I can think of. This is just some horrible stuff right here. Another one is sort of similarly awful, and this is one where the artistic rendition maybe doesn't do it justice. Trace 2b. This planet is so dark, it reflects absolutely no light. And so they've sort of like colored in here just so you can, like, this is cooler than just a black circle, which is really what scientifically would be warranted here. This reflects just absolutely no light that we can pick up on. And it's darker than any material, any kind of chemical that we can find naturally or produce in a lab on Earth. And so we don't totally know what it is, but the leading candidates for what's in the atmosphere for making this planet so dark are incredibly poisonous. Things like sodium and potassium, which, you know, yes, you need in some quantity for biological systems, but in vapor form in the atmosphere of a planet at 2,000 degrees, you probably don't want to inhale. Like, this is not going to do good things for you. And so, all right, I'm running out of time, so I'll wrap up. And the 10th one starts to look like home again. So Gliese 581d. This is heralded as the first Earth-like planet. This is starting to be the first candidate for Earth 2.0. And it was so exciting that there are now several, I've seen novels, movies, etc., about sending people to this planet. It was really, you know, sort of close to the Earth in size. It was in the so-called habitable zone where you could potentially have liquid water. The only problem is it doesn't exist. Turns out on closer inspection, the initial discovery of this planet was mistaking star spots. So, you know, you see these little sunspots on the star. When you measure stars looking for exoplanets, this can actually create a signal that looks like an exoplanet. And so I like to think of planning these space missions to send people, you know, loading them up on the rocket and sending them, and they start, you know, they get like 80% of the way there and call home and say, hey guys, where were we supposed to land again? Like, it's just nothing there. And so it's kind of a terrifying prospect and sort of unfortunate in that sense. This is how I get the name Darth Vader. And so I'll wrap up here.
Yeah, this question.
Hey, again, I'm in Louisiana, so I'll reference the bayou. Again, it's beautiful. The galaxy is this beautiful, immense place that probably supports life forms all over the place. But a lot of it really wants to kill you also, and I hope I can convey some of that to you tonight. Thank you. Hand up already.
No, you can't leave yet. Well, thank you. That was a fantastic talk. All right, so I've got the great pleasure of asking the first question, and I want you to ruin maybe my favorite planet, and that's going to be 51 Peg B. So please, why do we not want to go to 51 Peg?
51 Peg B is an interesting case because this was, when it was first appreciated that we could detect planets around other stars, we thought, well, this is decades away because the planets are, so far. You look at something like Jupiter, and it's big, but it's so far from the sun that its signal would already be kind of minuscule. But some enterprising astronomers in the University of California system, I'll go ahead and champion that, thought, well, let's look anyway. It turns out that a lot of stars host giant planets like Jupiter that are incredibly close to their star. And so you already don't want to go to Jupiter because it's this enormous planet. Again, there's no solid surface anywhere. I don't know what would kill you first. The cold temperatures, the immense pressure, the poisonous atmosphere. And so imagine taking that planet and putting it, 3 stellar radii away where the temperatures are now 2,000 or 3,000 degrees and would just vaporize you instantly. So 51 Peg B is an incredible planet because it opened this new world to us, this diversity of planets that the galaxy hosts that look nothing like our own solar system. But it's absolutely not a travel destination for you, sorry. Yes?
So, any planet that was actually Earth-like, or Earth-like enough to support life, wouldn't they have their own bacteria and microbes that would also kill us, but possibly in like a lengthier and more horrifying way? Where would those rank in your list of top 10 exoplanets that are the worst?
Okay, so the question was, suppose we found a really Earth-like planet that actually existed, would they not have their own, biological systems, potentially including bacteria that would kill us as soon as we took our helmets off on the surface? And I'll start by answering that question like a member of Congress. I'm not a biologist, and so I can't tell you exactly, but no, I wouldn't take my helmet off, okay? We have absolutely no immunity to any life forms that might exist on those planets. I think the real question is whether their biology is in any way related to our own. Like, would we want the same nutrients? Would we, compete for the same resources? Would they find anything in our bodies that they would find useful as food or a living host or anything? The worst possible answer would be yes, obviously. I think the best case scenario would be that we would sort of happily ignore each other, but obviously we would want to take extreme caution if we were to send people to one of these planets.
Can we expect them to be carbon-based?
Can we expect them to be carbon-based? I think conservatively, maybe. There have been a lot of speculation. There's a lot of speculation about things like silicon-based life, but there are chemical disadvantages to silicon-based life. Silicon is actually more abundant than carbon in the galaxy and the universe, and so if that were somehow advantageous, you would expect us to be silicon-based already. But silicon doesn't have all the same bonding properties or strengths as carbon, and so when you're talking about forming the long-chain molecules that form biological systems, carbon has a lot of advantages. And so never say never, but where carbon's available, you probably expect to see carbon over atomic alternatives like silicon.
The first planet that you demonstrated, it passes very close to its star. Many comets that do that same thing ultimately disintegrate. Is that planet losing mass, and if so, what's the timescale of its life?
Okay, so the question was, we see comets, the first planet I presented, which I don't even remember the phone number of, passes very close to its star like a lot of comets do. And we see comets disintegrating, and over even short timescales, they just completely blow away. The difference is this planet is very massive, and so that does two things. One, it has a very large mass reservoir that needs to be depleted, and two, it has more gravity, and so it can hold on to that material a lot better. And so we can't put a number on how rapidly that planet's disintegrating. We haven't made those measurements yet. But the time scale it would take for a planet like that to completely disintegrate is many times the age of the universe. And so we don't have to worry about that planet completely disappearing anytime soon.
On OCS 44, the one that doesn't have a star, how did they detect that? They just got lucky and found it?
Okay. So the question was, for the planet with no star, how do we even find that? It's a really interesting question. It turns out there are surveys. What we're actually doing is using something called gravitational lensing. So when a mass passes in front of a bright source like a star, you actually get a momentary brightening because that mass, because of Einstein's laws of relativity, it acts like a lens. And we survey a lot of stars looking for dark masses, okay? Talking about answering the big questions of what is this dark matter that apparently exists throughout the universe. And so looking for that, sort of as a side consequence, we find a lot of small objects that are passing through the galaxy and passing in front of nearby stars. And so whenever planetary mass objects that have been thrown out of their stellar systems pass in front of the star, we see a little brightening and can infer that there's some object moving through there.
So I guess I would ask, in conjunction with how this final stage was sort of structured, the galaxy is a lot like a biosphere, sustainable, and that's not life. But there is a ton of shit out there that wants to kill you. So if we were to buy the first part, which we already know that we're destroying the bio every day because, sea levels continue to increase upon actual water matters, how do we get to these other two things here that might actually want to kill us or anything else?
Okay, I want to make sure I understand your question. I think, are you asking, because of the fickle nature of life, how do we actually get to the point of traveling to other planets? Am I understanding the question?
Yeah. So how do we get there?
How do we get there? So I'm not announcing my run for president tonight. No, I mean, these are enormous questions, and if we could actually, contact
But I mean,
some.
that's the whole point of these things, is that we ask enormous questions and we want,
Sure, and there's something called the Fermi Paradox, which is, if there's even one life form in the galaxy advanced enough to travel from one star to the other, they should, within approximately 1 billion years, they should spread to every star system in the galaxy. And so the Fermi Paradox is, where are they? Why haven't they come here yet? And one of the possible answers to that is that there's some barrier in the course of evolution that keeps us from reaching that point where we can start to travel to the stars. And maybe that's nuclear warfare, maybe that's climate change. I certainly hope that's not the answer. But it's certainly a hurdle that technological species have to overcome. They have to save themselves from self-destruction before they can move throughout the galaxy. So that goes to one of those big questions, like, are we alone? And if not, how can we move out to make those first introductions with our galactic neighbors?
Cool, hi, I'm Ian. As Tyler said, I'll be talking about commercialization of space, what that means for us today, and how exactly we got in that position. So, let's start off at the beginning. NASA started 60 years ago, they just had their anniversary. And at the time, and for quite a few decades after that, only world governments were in the game of space. We had NASA, later on the European Space Agency, Chinese Space Agency, only governments. So how do we get from just governments controlling space to now quite a few different companies you might realize, or recognize some of the names up here? It all kind of started, or prompted rather, in 1982, when a private company decided to buy a refurbished missile from the United States government, and they launched a satellite in it. This is notable because it was the very first private company that decided to launch something into space. No, they did not develop the rocket, but they weren't the government, so it was a pretty big deal. A few short years after that, 1984, at this time, the moon races were over. It was 10 years in the past. NASA's budget was still higher than today, but it was declining, and the public interest in space was also declining. So the president at the time, Ronald Reagan, decided he would sign a Space Act into law to reinvigorate the public's interest, but also shift some of the monetary stuff off of NASA's shoulders. And this act allowed for private companies both to develop their own rockets and also their own satellites. So they didn't have to buy refurbished anymore. They could go out, do whatever they wanted. So 1990 was the first time people really took advantage of this law. Orbital, who is today, well, was actually known as Orbital ATK. They changed the name again early this year. They made their first privately developed rocket. Here's what it looks like. You've noticed that it's actually launched off of a plane, not typical of rockets that we see today. But interesting enough, this design is still being used today. They're still flying it today. And it's been pretty successful. They've done quite a few launches. Also interesting about this rocket is it's 3, possibly 4 stages, depending on what configuration you want it in. And the first 3 stages are solid rocket fuel, not liquid rocket fuel. So, kind of cool. To describe what a rocket is, for those of you that aren't familiar with the term stages and whatnot, I used a Lego model because it's easier to show and the pictures were easier to find. A stage is essentially just little parts of the rocket that break up, and they each have their own engines. And the reason this is the way it is, rockets are very heavy, and they have to get into space, and that takes a lot of fuel. So if you can have a fuel tank with its own engines here, and then once you get up closer into space, you drop it off, it's less heavy, it takes less fuel to push it further. So all rockets at this point are in stages because it's the only thing that makes sense. So going a little bit further, closer now, 2004, George Bush put a little bit more oomph into the Space Act, created a new amendment allowing companies to not just send cargo into space, but to send humans into space for the first time, not just to the International Space Station, but to wherever they wanted. And notably, he also told the Federal Aviation Administration, the FAA, that they had oversight over any matters into space, and more specifically, matters regarding people going into space per this act. But they weren't able to give any safety regulations until about 2012, which is the arbitrary deadline they set. They wanted to, before this point, allow companies to develop their own systems to learn through their own experiences. But notably, we haven't sent people into space yet. So this deadline was actually pushed back quite a few times. Now it sits at 2023. So we'll see if it gets pushed back again. Why is this important that we send people into space? It's more important than it was even in 2004 because we don't have any other ways to send people into space other than this rocket right here, which is the Russian Soyuz rocket. This is the primary vehicle that we use to send people into the ISS now, ISS being the International Space Station. And that's it right here for those of you that aren't familiar. So obviously a good idea not to be solely dependent on one rocket in another country, which is why they want people to start building their own rockets to diversify, and have it in America, it'd probably be cheaper that way too. So moving up a little bit more, the last sort of oomph that was put into the Space Act was by President Obama, when he said, not only can you send cargo and people into space, but now you can mine space. If you find it and you can get there, it's yours, you can do whatever you want with it. Nothing has been done with this yet, but there's quite a few companies that are developing techniques to find asteroids that have good mineable materials, and also developing these systems to land and capture said asteroids, possibly even bring them to Earth orbit to make it easier to mine. We'll see what comes of that. So now I'm going to start talking about some of the current companies that are employing these new technologies, new rockets, new ways to get into space. And I know everybody has their favorites. I'm sticking with just domestic companies, and I had to pick a few. So I'm sorry if some cool ones weren't covered. It's just way too much to go over. But I want to start off with Blue Origin, which is one that most of you probably have heard of. It was started in 2000 by a guy you're probably familiar with, Jeff Bezos, who owns and operates Amazon. And he actually got the idea, well, he was interested in space all throughout high school, but in the year 2000, he watched October Sky for the first time and said, this is a really cool movie, these kids building these rockets. I want to build my own rockets, so he did. Did a little bit later afterwards. In 2003 was the first time the public was actually made aware that this company existed at all. It was kept secret, and then they started buying land, and everybody thought it was for Amazon. So it was this weird mystery thing, and then he finally said, nah, I'm just going to build rockets on this land. So it was 2 years later, in 2005, when he actually showed off plans for the first rocket. I don't know if any of you have seen this before. It's called the New Shepard. And you'll notice it's actually pretty small for a rocket. It's just the first stage, and then this little capsule here on the top. And the main purpose of that capsule going into the future is to bring people into space. It's more of a space tourism thing than it is satellites or cargo or anything like that. So you can see here in this slide, just focus on this part, we'll get to this later, but this is the New Shepard flight plan. It lifts off, goes just above the Kármán line, which sits about 100 kilometers, I'm sorry. And it's the generally agreed upon line of space. So it's just in the space, it hovers there for a minute or two, you can take some pictures, and then it goes down and it lands the first stage, just a little short ways away. Notable about this, not only the fact that it lands the first stage and the fact that they've done this before, granted not with people, they did it before SpaceX did it. Not a lot of people know that. So I'll get into why people don't know that later when I get into SpaceX. But just know that they did. It's a pretty cool rocket. But it's not the only thing that they do. They also build their own engines and supply them to ULA, the United Launch Alliance. I'll get more into what they do later. In addition to also having NASA contracts to bring supplies to the International Space Station. They've been developing this new rocket called the New Glenn. It's just in development now. They haven't built anything, they haven't tested anything. This is what it looks like. And it's a pretty big rocket, to give you some scale. This is the New Shepard, the one I showed you before, and this is the New Glenn. So it's more of a launch provider in the sense that they're going to do satellites and such, but they want to get out of just low Earth orbit with this rocket. This is really the one that they're hedging their bets on. And going back to the New Shepard for a moment, I should mention that they're going to start selling tickets probably this year for about $200,000 to $300,000 if you want to go into space. Now's your chance. But outside of these avenues, selling tickets and getting some contracts, they get most of their funding directly through Jeff Bezos. He actually liquidates about $1 billion in Amazon stock every year, pours it directly into Blue Origin. So he's got the money, but good for him. They're doing some pretty cool stuff. Moving on, SpaceX, probably the one that most of you are the most aware of, and the one that's, in my opinion, done the coolest and the most things, was started by Elon Musk in 2000, another billionaire. You can see the trend here. He didn't have the same type of origin story, but along the same lines, he wanted to, he's always loved space, he wanted to reinvigorate the public with the idea of space, and he wanted to do that by sending a greenhouse to Mars. Maybe a little bit, idealistic. I don't know if he could do that, but he wanted to do it by buying Russian ICBM rockets and then sending it off that way. So he went to Russia a few times to ask about procuring these rockets, and they quite literally laughed him in the face and said billionaires shouldn't play with toys like that. And the lead designer of the ICBM spat on the shoes. So a little discouraging. He didn't take it badly though. He decided, okay, well I'm going to do a 360 and I'm going to build my own rockets and learn how to do it by myself. So he did exactly that. And in 2009, he launched the Falcon 1. It just has one engine, and then the first stage, and then a tiny little second stage, and the payload. They only had enough money for... Sorry. They only had enough money for about 3 launches. The first 2 exploded, one on the pad, one after it went up. But the third one was successful, and NASA was really impressed by this. So they gave SpaceX $1.6 billion to develop a system, or just use the Falcon 1, however they wanted, to get stuff to the International Space Station. So in 2009, like I said, they were the very first, well that was when the Falcon 1 was successful, and that was the very first time that a company developed its own rocket and sent something into space, a satellite. So shortly after that, once they got the funding from NASA, they decided we're ditching the whole Falcon 1 thing, and they moved up to the Falcon 9, and full steam ahead on that, launched that, it was successful. 2012, they made good on their agreement with NASA, and they started delivering stuff to the International Space Station, which is something that they still do today, recovery as well, not just delivery. 2013, they started the Grasshopper Program. So to explain this a little bit, it's that first stage I mentioned is the one that they cast off first. It's usually the biggest stage. So it's a major part of the rocket, and if you can get that part back, then you can save a lot of money, because then you have the ability to possibly reuse it. So the Grasshopper Program was when they took the first stage of their Falcon 9 rocket, and they flew it up a little bit, and flew it down and tried to land it. It exploded a lot of times before they were able to finally land it. But then once they were able to land it, they started flying it higher and higher until it went almost like 2 or 3 miles in the air. And then after that, they said, okay, we think we know enough, we're gonna try to land it ourselves with a real rocket. So they started this program in 2013, and you can see, I'll show you why the SpaceX landing is the one that everybody usually knows about. So compared to the New Shepard, it goes about twice as high at 200 kilometers, twice as high as the Kármán line. And in addition, because it's an orbital rocket, it goes a lot more horizontal. So it has to scrub off that horizontal velocity. This is how the rocket keeps going afterwards. But the first stage turns back, and then has to land itself from that much higher, that much faster, much harder. So when they did it, that's why people usually pay attention to that. It's considered the real first landing because it actually went into space and whatnot. Anyway, 2014, the following year, NASA awarded them $2.6 billion to send people to the International Space Station, trying to take advantage of the law that was signed in 2005 that I mentioned before. Next year, Falcon 9 did its first landing. This was on land. And the year after that, it did its first landing on water. So the difference here is also important. If you land on land, you have to slow yourself down a lot more and make sure you get back to one specific spot. But if you land on water, you don't have to slow down as much, and you can kind of move a ship wherever you want to. That's the whole point of water. So if you can save on fuel, you can launch things higher into space because you can use more fuel, and it's much easier to catch. You have a lot more flexibility. So the fact that they do drone ship landings is pretty significant. 2017 was the first time that they reused one of the rockets that they landed. And as I said, the first stage is a pretty significant portion. So being able to reuse just this one stage per launch saves about 75% of their entire launch cost, which comes out to about $21 million. So decent savings. And then in 2018, last year, was when they launched their Falcon Heavy. And instead of trying to explain this, I want to show you a video of that launch and of that landing, and then I'll try to commentate as we go along, but it's pretty cool. So. This is the Falcon Heavy. Heavy, you'll note that on the sides, it's actually just 2 Falcon 9s basically taped to it. So another pretty cost-effective method of having a big rocket. But because there's essentially 3 Falcon 9s, there's one in the middle as well retrofitted, you can launch higher mass stuff. So here's the stages coming off of the main middle booster, and these are each cameras on the stages as they descend down back to Earth. So you can see here's itself lighting the engine, trying to slow itself down, and the 2 stages with the pads in sight, that's these pads. And as they come down, you'll see the 2 stages right next to each other, landing almost simultaneously. So, pretty cool, but that's not even all of it. This is Elon Musk's personal Tesla Roadster that he used to drive all the time. When you send up a rocket, you have a dummy payload to simulate high mass being in the rocket. So instead of sending up a block of concrete or water, which is what people usually do, he sends up his car with a dummy in it, wearing the official SpaceX spacesuit that was designed for the astronauts they're going to send to the ISS. So pretty cool. And there's other little Easter eggs in there, but I'll let you find out for yourself or if you have questions later. And they had a live stream of this going for like 16 hours. It's pretty cool. You can, if you want to look that up later too, I highly recommend it. Anyway, so the Falcon Heavy was what they planned to use to send people to Mars. And this is what the inside of the Dragon capsule, which is their cockpit, looks like. You'll notice it's very big and spacious compared to what older cockpits look like with all the complicated buttons and such. And they have just screens and a few buttons. It's supposed to be really comfortable, really pretty, obviously. They decided very shortly after this that they didn't want to use this to send people to Mars. They were developing something new called the BFR, the Big Falcon Rocket. You'll notice it is pretty big. So here's it right next to the Falcon Heavy, and also the amount of mass that it can take is at a staggering 150 tons. So either you can bring a lot of stuff into space, or you can bring people to Mars. Either way, pretty significant rocket. And it actually, with its Grasshopper unit, so I mentioned the Grasshopper test, it's going to go through its same test because they want to try to reuse such a big rocket. It's going to start very soon, and they just finished the test unit. Here's a little dummy with a SpaceX suit to scale. And this is an actual picture, not a rendering. It's going to be shiny and such too. So its maiden flight right now is scheduled to be in 2023. And it's pretty cool, not only because they're going to be taking it around the moon, which we don't really send people to the moon anymore, but this guy, Yasuka Maezawa, is another billionaire who decided he wanted to buy out tickets for the entire rocket. They had 100 seats. He said, I want all of them. And he wasn't going to fill all 100 seats, and it wasn't just going to be him. It's even cooler because he decided he was going to send 6 to 8 artists from around the world for free around the moon with him. And then a year or 2 following the moon mission, they were going to have an exhibit showcasing all the art from the inspiration from the moon. So pretty cool, pretty philanthropic. Keep your eyes out for that. And they plan to fund the majority of this BFR mission to go to Mars and such with Starlink, which is their aim to have a global internet, basically global satellite internet. They want to launch 4,500 satellites up into space, which might not sound like a huge number when you talk space numbers, usually very big, but currently there's only about 1,800 satellites in space, so they want to more than double all of the satellites in space right now. And they have permission to do this, and they've launched a few test satellites already. So it's going to be pretty big, and they're going to get a lot of money from it. Moving on a little bit, though, to my last company that I want to talk about, ULA, United Launch Alliance, formed in 2005. And as their name suggests, they are an alliance between 2 other companies, Boeing and Lockheed Martin, 2 companies that have been around in space for quite a long time, working very closely with NASA and the US government. They quite literally just got together and used the same rockets that they already had. So, namely the Delta IV and the Atlas V are the 2 rockets that they use the most. And they actually had a little bit of a legal run-in with SpaceX shortly after their inception. SpaceX said that they were having essentially a monopoly on all of the contracts. And if you look, this was pretty much the case. Even though ULA's launches were 2-3 times, sometimes 4 times the price of SpaceX, all the contracts were at ULA. So they brought it up with the FAA, who I mentioned is now in charge of all the space stuff, and they sided with SpaceX, put in some antitrust laws, and that caused ULA to downsize, which could have actually been a very good thing, because after this they decided, hey, we can't build our business off of just sending rockets for the government. We need to send rockets carrying payloads for any private company that wants to purchase from us. So they also decided we need to sort of expand what we have to offer, and they created the Delta IV Heavy, which is basically the Delta IV, like the Falcon Heavy, just has its first stages kind of taped to the side of it. Not really taped, but more cost effective and can take heavier stuff into space. And they're currently developing a rocket called the Vulcan. It's still in development, so I can't really tell you much about it other than it's supposed to be really big and very powerful. So look forward to that. And they were also awarded a multi-billion-dollar contract with NASA to send people into space. This is actually the team that they already selected, and this is the Starliner, which is where they're going to be on top of their Atlas V rocket. Here's to scale, so it's going to be about that big. And they hope to do an unmanned test flight sometime later this year. I forgot to mention, but SpaceX is also doing an unmanned test flight tomorrow. So if anybody wants to watch that, they have a live stream, you can check it out. The point I'm getting, though, with all these companies is not to just keep going into specifics, but more look at the bigger picture. With these laws in place that allow you to mine asteroids, send people into space, and with these companies that are building rockets that actually have the capability to do these things and to innovate, to land them, to reuse, the things that you can think of are pretty much endless. And the things that they're planning to do not only are very cool, but they're going to happen very soon. So like the colonization of Mars, Elon Musk plans to do that in the 2030s and send people back into space in the 2020s. So this stuff is really right there at the door. And I hope learning more about the stuff that they're currently doing to employ these new technologies to reach these goals is something that it gets me really excited, but I hope it gets you really excited too. But before I end the talk, I mentioned that a lot of these rockets tend to fail a lot. So SpaceX, back when they were all the way doing their Grasshopper test, decided to start a blooper reel of all the times that they messed up and their rockets didn't quite land. So as a send-off, I wanted to play the blooper reel so you can see sort of what goes into testing these rockets and creating these new technologies.
So we went from Falcon 1 to Falcon 9. Tell me, what's going on with Falcons 2 through 8?
Yeah, so they're rocket scientists. I promise they're not totally dumb. As I mentioned before, the Falcon 1 only has one engine, and the Falcon 9, you might guess, has 9 engines. So that's sort of how they skipped the numbers, just dependent on the power of the rocket. Yes?
Now that China has landed a lander where no one has landed one before on the dark side of the moon, do you anticipate that this is the beginning of another space race?
Okay, so the question was, now that China has landed a lander on the opposite side of the moon, which is something that nobody's done before, do I anticipate a new form of the space race? I do, but probably not in the way that you're getting at. I think there will be an initial race back to the moon, just because that's the most prolific thing we all have in our minds when we think of going into deep space. But I think this new space race will really focus more on going to a place like Mars or colonization, just the more bigger pictures. I think that's really just more of the beginning stepping stone of what's to come. Okay, so the question is, are there other companies that are getting into this space race that are sort of up and coming? I only highlighted 3 companies, but there are dozens of companies that are creating their own rockets, developing their own satellites, doing private launches, and then even trying to get into space tourism. So mainly a company like Virgin Galactic. They don't really do payload launches, so I didn't really focus on them, but they have sort of like a space plane that kind of fly into space, and actually I think they recently did go above the Kármán line, so technically it was the first American citizen to launch from American soil to get into space. But yeah, there are other companies that are doing this, and I could have gone on and on about all the companies. Yeah, so the question is, so there's a company called Rocket Lab, another one of the many space companies that are getting into this business of building rockets, developing their own launch, providing services. They have small rockets, and the question was, how do I see that playing out when all of these companies building really big rockets? I think they are very, very necessary and will probably do very well, because not everything is huge payloads, especially as we get into like CubeSats, which are just little cube satellites, small things like that. Even if you just don't have a huge payload, a lot of these launches actually have multiple payloads, and they're smaller payloads, but they just clump them together because it's more cost effective. But there's still a huge market and an ever-growing market for launching a lot of these small satellites, and I think they're very necessary, and they're going to do very well.